So here is our starting model. Okay, some geometry defined, and what we're going to show is how we go from this to our finished design part, like so. Okay, so inside, going to generative design, and that will launch generative. Now this has already been set up, so don't want to bore you with all that process. So essentially we've got our initial geometry. You can see here the sort of shaded, transparent shaded geometry. So that's our starting geometry. So that's basically what we can change around, what we're free to let the engine solve inside that space. We've got our preserved geometry here. So you can see we've modeled this as bodies. This is one of the reasons that multi-body was introduced in Creo 7, was to have these different bodies to represent the different bits of geometry they're going to work with. So these are our interfaces. And then we've got some excluded geometry, which is currently hidden, which I can show there. So you could just model that inside the envelope if you wanted to, but sometimes it gives you a little bit more flexibility having it as a separate body. Okay. So we define those just through following along the top here, okay? And then we've got some loads, okay? So we've got some constraints. So just fix that geometry. We've got two different structure loads here. We've got some forces pulling out, and we've got a second set of second structure where we've got, again, the same constraint, but in this case, we've got some loads pushing up on the bottom, okay? So we define all of those. That's our initial setup. And then we go in and we define our design criteria. Okay, so we've got a design criteria here that's been set as active, so we can just have a look at that. So we define our design goals in the criteria. So we could choose to, in this case, we're maximizing stiffness, and we want to limit the volume to 30% of the, that sort of initial envelope. We could choose to minimize mass, and then we can work to a safety factor that helps us drive that. Okay, but if we switch back to the stiffness and limit the volume, and then we can add design constraints in here. So we've got a symmetry constraint already defined, okay, where we're picking, we want to keep it symmetric about the midplane there, and we can add other constraints in here as well. So build direction if we're looking to reduce supports. So this isn't just limited to additive. This is one of the great things about it. We can define that we need a parting line in there if we're going to be looking at molded or cast parts. Linear extrude, so that way we can make sure that we can basically come in from one direction if we want to machine this thing. Symmetry, we've got material spreading in terms of how our material forms if we're maybe looking to mold this. We have minimum crease radius, again, which can help with machining and web sizes and the like as well. So we can add multiple constraints in here. We've got our material defined that came from the part, so we can set up and define that. Okay, so as I said before, we can define multiple design criteria inside this. So there's a first criteria. You can see them in the tree. It shows what they've got. We've got a second one here, which is the same, except we're also adding in, we're going to extrude this 3 degrees. So we might want to machine this, okay? So once we've set that up, we can then choose to run that optimization. So this first one's already been run. There's my results. It took 52 seconds on my machine, which isn't very long at all, but can feel like an eternity when we're all sitting on a webinar watching the screen. So I ran it ahead of time. So basically it runs, and this is the end result that we see. So once we've run that, we can choose to look at the simulation results. So we can see, our structural analyses, 1 or 2, and what that gives us in terms of stresses or displacements or safety factor results. Okay, so we can go through and check that we're okay with that. We choose to animate that if we want, just like you do in normal simulation results. If we're happy with all of that, we can choose to then generate that design. So we can say either into the current part or a new part, whether we want to work with the tessellated geometry or we actually want to reconstruct that automatically and create those surfaces and go off and generate it. And that's literally what I did. I just hit that to generate that model, and I waited about 1 minute, and basically what I got was the model that I showed you before, like that. I didn't have to do anything else, and there's my finished solid part. Okay, so once it's finished, you can see basically what it builds for me is all of this stuff. Okay, so it basically goes and creates all of the geometry in there, can create some curves where it intersects, creates the freestyle surface automatically, which is fantastic because there's no way I'd want to try and build that myself, and then turns that into a solid, so we end up with our finished model. But at any point that model saved out, I've got that generative feature where here I can go back and choose to edit that study and change how that's being run, okay? Like so. So that's the generative process. So just to, I'll start it, but I won't let it run because it takes a while. So as I said, we can have multiple criteria, okay? So I've got this one as active. If I go and make design criteria 2 active, that obviously resets my results, okay? And now I can choose to run that optimization, okay? So that will basically start the process based on these constraints, okay? I can see how see its progress, and it starts to animate and show the model as it's building it, okay? So we can start to see what it's coming up with, okay? Step by step, you can change how quickly it shows those steps. You can see if I'm looking at it from this direction, or if I come underneath it, you can see it's a flat surface, right? Because I've said I'm coming in one direction. Okay, so I'm now going to be able to essentially come in from the top and be able to machine that if I need to do it that way. Okay, so that takes about a minute and a bit to run. So we can just let that run in the background. Okay, and that's GTO running inside Creo. All right, so very quick and simple to use.